Today we are starting section 11.3. We are going to use properties of arcs and circles. First, warm up. If the radius of a circle is 7 centimeters, what is the diameter? So what you should be writing down in your notes would be something like R equals 7 centimeters. And then also a D equals, so we can fill in what the diameter would be. Who can raise their hand and tell me how radius and diameter are related? 2 radii would make up a diameter. So what would our diameter be?
14.
14 units are
centimeters.
Next, warm up. What type of angle is formed when a radius of a circle connects to a tangent line? Jordan correctly told us that a right angle is formed when a radius connects to a tangent line. Last warm up. Draw a diagram of a tangent and secant. In order to draw that diagram, you will first have to draw a circle. So I will give you a moment to do that before we talk about what that will look like. You should be able to do that on your own. Think about where a tangent would touch a circle and where a secant would touch a circle. Not everyone's diagram will look identical, and that's okay. Who can raise their hand and tell me how many times a tangent will touch a circle? Kiatha. Once. A tangent line will touch a circle 1 time. So you should draw a tangent line where it touches the circle at just 1 point. Who can raise their hand and tell me how many times a secant line touches a circle? Connor? 2 times. So your secant line should somewhere cut through your circle so it touches the circle edge 2 different times. Your diagram could look different than mine. You could have put your tangent or secant lines almost anywhere around the circle as long as tangent touches once, secant touches twice. First thing to fill in your notes is some terminology for circle D. Remember, we name circles by their center, so this diagram has a center at D. You should label the diagram. Yours is on the left, underneath where it says notes. All right. If you have not already done so, you should be filling these in as we go through them. AB is called a minor arc. So as you'll notice on our circle, A and B are both points on the circle. So AB is called an arc. It's part of the circumference of a circle. It is curved. It is not a line segment. It's called an arc. It is called a minor arc because it is less than half of the circle or half of the circumference. It's a small arc, minor. Arc ACB, which means we start at point A on the circle, we have to pass through point C on the circle, and then ending at point B. That is called a major arc because it is more than half of our circumference. You can see that ACB takes up much more than half of the circumference of the circle. Angle ADB, this angle here, so we would start at point A, go into point D, out to point B, is called a central angle because the vertex is at the center. Central angle, vertex is at the center. At the bottom there, it says an arc is named by its endpoints. A minor arc uses 2 letters. And a major arc uses 3 letters to name it. All right, next up we've got a few definitions. The measure of the minor arc is the measure of its central angle. As we said before, it would be less than half the circle, so it's got to be less than 180 degrees. The measure of the major arc is the difference, which difference should make us think of what operation? Subtraction. The difference of 360, which would be the whole circle, and the measure of the related minor arc. So a measure of a major arc is always greater than 180 degrees. A semicircle is an arc whose central angle measures 180 degrees. So a semicircle would be half of the circle. They would still name it with 3 points. On our examples, we have to identify each arc as either major or minor, name it, and then find its measure. Go ahead and put all 3 of them up there. So on each of these, we have 2 different arcs. Anytime you have one arc, there are actually at least 2 different ones. So for each of these, we will have a major arc, we will have a minor arc, and we will be able to find both of their measures. On number 1, let's start with the minor arc. Jordan? RT. So the minor arc is arc RT. The measure, so I use a little m, of arc RT is the same as the measure of its central angle. Who can tell me what the measure of arc RT's central angle is? Julian? 50 degrees. An arc measure is the same as its central angle. If we had a minor arc, there is also going to be a major arc on that same diagram. Remember, major arcs we have to name with 3 letters. So if we already named RT, that part's been used up. 42. We can start at R, but this time instead of going directly to T, we'll go the other direction. So if I start at R, what point am I going to pass through? M, and then I'll wrap around and end up at T.
Is it the same thing with major arcs, like they're going to have a minor?
Yes, major and minor arcs will always go together. If you have a minor arc, you'll have a major arc associated with it, and vice versa. So I'll highlight the major arc in green, just tracing around it. So if you have a major and a minor arc that go together, they should make up the whole circle. So in order to find the measure of our major arc, or the measure of arc RMT, what do we have to do according to our notes? In order to find a major arc, we have to take 360 and subtract the associated or related minor arc. So our minor arc was 50, 360 minus 50 gives us 310 degrees. All right, on number 2, we are going to need to first identify our minor arc. Who can raise their hand and tell me what points make up the minor arc? Jaden. What is it? AB. So our minor arc is arc AB. A minor arc only uses 2 letters. I need someone new to raise their hand and tell me what the measure of arc AB is. Somebody I haven't heard from yet today.
Y'all don't raise your hand.
The measure of arc AB is 42 degrees. All right, I also need to identify my major arc. Our major arc is named with 3 letters. So we would start at one of the points. A is a good choice. Travel through D and end up at B. That covers everything that our initial arc did not touch, the rest of the circumference. We are also going to have to know the measure of that arc. I would agree the measure of arc ADB would be 318 degrees. We take 360 minus the minor arc, and that's how we get the major arc. All right, on number 3, I need somebody new to raise their hand to tell me the name of the minor arc. Cade. The name would be arc EF. We just use the 2 letters of the small arc, the minor arc. We also need to know the measure of that arc, EF, IKEA, 63 degrees. We get that from the central angle that makes it. Next, we have to identify the major arc using its points. So if you kind of cross out or mark off the minor arc EF, choose one of its points to start at, travel around the circle so you don't go through the minor arc. That should give you the points that you would use to name the major arc. Our major arc is arc EHF. So then we also have to be able to find the measure of that arc. Do we agree with 297 degrees?
Yes.
We should. We take 360 and take away 63. We'd end up with 297. Next up, we've got congruent circles. 2 circles are congruent circles if they have the same radius. 2 arcs of the same circle or of congruent circles are congruent arcs if they have the same measure. Congruent circles would have the same radius. Congruent arcs would have the same measure. On these examples, we have to name the arcs and decide if they are congruent. So I will trace over the ones that I want you to name and decide if they're congruent. We're not necessarily doing every single arc. There are lots of arcs here. So I will trace over them in red. And we will go through and decide after we name them if they are congruent. All right, on number 4, so I've traced 2 arcs in red. I need someone that I have not heard from yet today to raise their hand and help me name those 2 arcs. Our arcs are AB and DC, and we have to decide if they are congruent. Jaden said that these are congruent, and I would agree because they both measure 80 degrees. Both of these central angles that they came from had a measure of 80 degrees. So the arcs would be congruent. Our arcs on number 5 could be called AB and CD. And then we have to decide if they are congruent or not. Jordan. So they do have the same measure, but they don't come from circles with the same radius. So are they congruent? No. So these ones are not congruent because the circles are not congruent, or the circles do not have the same radius. So you could say circles not congruent, or circles don't have the same radius as your reasoning for saying that they are not congruent. Arc length is a portion of the circumference of a circle. To find arc length, we set up a proportion which has the arc measure over 360 set equal to x over 2 pi r. So you might want to note that x represents the arc length, so that's usually what we're trying to find. And of course you should know that r represents the radius. The arc measure and the arc length are 2 different things. Arc measure, we use degrees. Arc length would be some distance units, something like meters, feet, yards, centimeters, inches. So length is some sort of distance unit. Arc measure is measured in degrees. All right, I'm going to walk through setting up number 6 so that we can get it done together. The arc measure. If we're trying to find the arc length of arc AB, the measure of that arc in degrees is the same as the central angle. It would be 100. We always put the arc measure over 360 because that represents the entire circle. Equals, we use x to represent that length that we're trying to find. We don't know what it is yet. Over 2 times pi times the radius, which in this case is 5. Before we cross multiply, we could simplify that a little bit. 100 over 360 is equal to x divided by 10 pi. If you prefer to multiply that 2 and 5 together, that might help. To solve a proportion, we have to cross multiply. So that means I take 360 times x equals, we have to take 100 times 10 pi. For now, I'm just going to write it as 1000 pi. If you already changed it to a decimal by multiplying by pi, that's fine. In order to get x alone, I'm going to have to do what to both sides? Divide by 360. So in my calculator, I would take 1,000 times pi, press equals, and then divide by 360. I need someone to raise their hand to tell me what they get for x. David.
I'm not sure if it was right, but I got 8.72.
What'd you get?
8.72.
Did anybody else get 8.72?
Yeah, maybe, I don't know.
8.72. What would our units be?
Centimeters squared? No,
Just centimeters because we're not finding area. All right, on number 7, I need somebody to set up my initial proportion. Jordan. 90 over 360, so our central angle over 360 equals x over 2 times pi times 4. I would agree with that if you want to go ahead and write it as 90 over 360 equals x over 8 pi, or you want to go ahead and multiply 8 times pi, that's fine. I don't like to multiply by pi until the end. It should not really affect your answer, though, if you multiply it earlier. When we cross multiply, we would have 360x equals 720 pi if you didn't multiply it yet. If you just multiply the 8 times 90. What do I need to do to get x alone? Divide by 360. And what do we get for x? 6.3 if you round to the nearest tenth is fine.
I didn't round it in.
And then you put your x, and then you put it over 8 feet. With pi.
What else?
But like, I mean, you put pi r again.
What do we need with the 8 pi, Julian? A 2. So it's 2 times pi times our radius. 2 times 8 is 16. So I'll go ahead and go straight to 16 pi. Yes, what do we get when we cross multiply?
360x equals 506 pi.
Okay, what do we do after that? Divide by 360. What do we get for x?
I don't know if I did this right. 2.6.
Anybody agree with 2.6? No? Jordan, what'd you get? 8.4.
That's what I got for final.
Okay, for a final answer, that's what I was going for. Final answer, 8.4 feet.